If you had to design the overhead lines for a train, how would you design it? Like this? No, I don't think so. Just like this. Once the temperature rises, the overhead wires will start to expand and slowly fall. When the train's electricians come into contact with the overhead line, that's what happens. And if the temperature drops, the wire begins to shrink again. Eventually, it breaks. Ideally, overhead wires should be kept straight and stretched. So how can we improve it? It's like this. Add a pulley to one end of the pole, then attach a weight to the end of the wire. That way, the overhead line will be much straighter. Even if it expands and contracts, the wire can be adjusted for expansion and contraction. But when we want to increase the distance between the poles, that's the problem. Once the distance between two poles is too great, no matter how much weight we add, the overhead wires will not reach the ideal state. The engineers found that after many tests, to keep the overhead line in a stable position, the distance between the two ends of the pole must be limited to 50 meters, and the distance between the two ends needs to be increased by adding multiple support columns. The cantilever of these support columns is not fixed. They can be rotated at an angle to cope with changes in length due to temperature changes, to keep the trains running. We'll need a lot of overhead wires. How do we do that? It's easy to copy and paste, but this way. The two sets of wires are not connected to each other. How can we improve that? We can do it this way. We'll add a jumper directly to the connection. That way, the train can move smoothly and quickly from one set of wires, and then the train can go from one set of overhead wires to the next, smoothly and quickly. But is it really perfect? Let's take a closer look. There's still a certain amount of curvature in the wires. For a high-speed train, it's still a safety hazard. Let's move on. Let's take a set of overhead wires. Make a copy. Then we'll go up the whole length and add a couple of connecting wires between the two wires. That's 1/9. The lower wire will be lifted up as we place more connecting wires. The more wires we place, the flatter the overhead line will be. After the improvement, the wires are kept in a parallel line. And there's another advantage to this design. It reduces the vibration of the cables. But can it be made any better? Let's see here, the wire above. It could be connected directly to this pulley and move the weights from the top to the bottom. But the problem is with the weights. The change in the overhead line isn't noticeable. What to do? According to 9 years of compulsory schooling, one pulley saves half the force. We'll introduce two sets of pulleys like this, and then we'll have an almost straight overhead line, an improved overhead line. That's all it takes to make a train run fast.